Metals and their alloys are an integral part of construction industry as they are employed for various purposes. Chosen for their durability, strength, and resistance to weather, metals used in the construction industry serve a wide range of functions. Learn more by watching this video. You are in construction materials and testing. Metals are classified into two based on their iron content. Those which contain a fair amount of iron are categorized as ferrous metals. The most popular examples are cast iron, wrought iron, and steel. Non-ferrous metals contain no iron but also include some alloys that contain appreciably very small amounts of iron. These are generally more expensive than ferrous metals, but they are still used because of some desirable properties, such as low weight shown by aluminum, high conductivity of copper, and non-magnetic property and high resistance to corrosion exhibited by zinc. There are different construction metals and not just the reinforcing bars which we are familiar with. First is aluminum. Aluminum is commonly used in the industry because it is resistant to corrosion, highly conductive, and ductile. Because it is resistant to harsh weather, the metal is used in windows, doors, and wires, as well as outdoor signage, street lights, also with heating, ventilation, and air conditioning ducts. The other type is copper tubing. Copper itself is ductile, malleable metal which is resistant to corrosion from water and soil, and is also recyclable. Copper tubing is also easily soldered, forming lasting bonds. Copper tubing, which comes in two main types, is often used to construct pipes in buildings. Rigid copper tubing is ideal for hot and cold tap water pipes in buildings. Soft copper, on the other hand, is frequently used to make refrigerant lines in HVAC systems and heat pumps. Next is stainless steel. Stainless steel is among one of the oldest known building materials. It was used centuries ago to construct structures that still stand today, thanks to the corrosion and stain-resistant properties of the metal. It is an alloy of several different metals, the amounts of which can be adjusted to create different grades of stainless steel with different properties. Next in the line is cast iron, which is formed by remelting pig iron. The products of cast iron exhibit reasonable resistance against corrosion. The cast iron is neither malleable nor ductile, and it cannot be hardened like steel. Cast iron has a wide range of applications, including manufacture of wrought iron and steel. Wrought iron is the purest form of commercial iron. Due to the presence of siliceous slag, its structure is fibrous and it gets anti-corrosive properties. At present, wrought iron is used for chains, bolts and nuts, roofing sheets, and others. It is used in the manufacture of steel. Galvanized iron is essentially iron that's been coated with a protective zinc layer on the outside. Iron itself is susceptible to weather-related degradation. When exposed to moisture and oxygen, for example, iron will rust and corrode. Over time, the presence of the rust and corrosion can eat through the iron, essentially jeopardizing its structural integrity. Thankfully, galvanization offers a simple and effective way to protect iron from weather-related degradation such as this. Steel is an alloy of iron consisting of carbon as a hardening agent. Besides carbon, there are many metal elements that are part of steel alloys. Details on steel will be discussed in the next video. Pig iron is the product of smelting iron ore, also ilmenite, with a high carbon fuel and reductant such as coke, usually with limestone as a flux. Charcoal and anthracite are also used as fuel and reductant. Pig iron is produced by smelting iron ore in blast furnaces or by smelting ilmenite in electric furnaces. In a later discussion, we are going to differentiate the different types of steel, but for now, let's differentiate wrought iron and mild steel. While wrought iron and mild steel resemble each other, there are certain distinct advantages of wrought iron which cause it to be retained for some uses. Among these advantages are, first, it welds better than dust steel. When applied with heat, wrought iron melts in a finer texture than steel. Second, it lasts longer when exposed to weather or to water. Although both materials are corrosion resistant, being exposed to weather and water will surely aggravate corrosion, and wrought iron will be able to stand it longer than mild steel. Third, better to resist fatigue. Wrought iron is more malleable than mild steel. And lastly, its fibrous structure arrests fracture. As its breaking is in the nature of a gradual tearing, the presence of siliceous slag can help in the gradual tearing in case fracture occurs. Among the disadvantages of wrought iron are, first, its elastic and tensile strength are lower than those of steel, which means steel is stronger in tensile tests. And production of wrought iron will be more expensive compared to the manufacture of steel.